The desert does not look like a doorway. It looks like an ending. Sand runs in pale sheets toward a horizon without mercy, broken here and there by stone ridges, dry riverbeds, and the ghost shapes of old lakes that no longer hold water. Yet in another age, under another sky, this same emptiness changes its face. Rain moves farther north. Grass spreads over the low ground. Herds follow the green. Birds gather over temporary lakes. Rivers that had been dead for thousands of years begin to move again, not always strongly, not always for long, but enough to stitch together a passage across lands that later generations would remember only as barriers. Somewhere in that shifting world, a small group of Homo Sapiens steps beyond Africa, carrying stone tools, fire, memory, hunger, skill, and the quiet confidence of people who do not know they are becoming part of one of the strangest mysteries in human history. They do not know they may vanish. Not vanish in the dramatic way that cities vanish under ash, or islands disappear beneath the sea, or empires collapse into ruins. Their disappearance is quieter than that. It happens in bone, in climate, in distance, in the fragile mathematics of survival. A group can endure for generations and still leave no obvious descendants. A trail can cross deserts, coasts, forests, and mountains, then fade until only a tooth, a tool, a faint layer of ash, or a broken genetic signal remains. These people may have found water, hunted animals, crossed valleys, buried their dead, learned unfamiliar skies, and met other kinds of humans already living beyond Africa. Yet when scientists look at the ancestry of most people outside Africa today, these early travelers are strangely hard to see. It is as if they stepped through a door in deep time, lived for a while in the rooms beyond it, and then the rooms went dark. Before we go deeper, take a moment to like the video and subscribe. If this is the kind of history and mystery you enjoy, the story begins not with one grand departure, but with a series of attempts. For a long time, the simplest version of human origins was easy to imagine modern humans evolve in Africa. Then one successful wave leaves and spreads across the world, replacing or absorbing everyone else. There is truth in that broad shape, but the closer the evidence is examined, the less simple it becomes. Fossils, stone tools, ancient climates, and DNA now suggest a more restless history. Homo sapiens did not wait patiently in Africa until one chosen moment. They pressed outward again and again when the world allowed it. Some groups reached the eastern Mediterranean far earlier than the great expansion that later populated Eurasia. Others may have moved through Arabia during wetter intervals, following lakes and grasslands that vanished when the climate turned dry. Some traces appear deep in Asia, in places that seem almost too early, too distant, or too faint to fit comfortably into an old straight-line story. What survives in the record suggests that leaving Africa was not a single leap, but a rhythm. The Sahara and Arabia open, then close. A green corridor appears, then dries into a wall. Coasts provide food, then seas rise and drown old camps. Forests expand. Deserts shrink. Rivers cut pathways through land that later becomes hostile again. To people living through it, these changes are not abstractions on a climate chart. They are the difference between a valley full of antelope and a valley of dust. They decide whether a family group can move another season, whether a hunting band can return to a known spring, whether distant groups remain connected or slowly lose contact until they become islands of people in a vast landscape. This is where the mystery grows deeper. Many of the early journeys out of Africa may not have failed in the way the word usually implies. They were not necessarily brief, foolish, doomed wanderings. Some may have lasted thousands of years. Some may have adapted to new animals, new plants, new stone sources, new seasons, and new dangers. They may have lived well for long stretches of time, but from the viewpoint of later ancestry, they are lost. Their descendants may have dwindled, merged with other populations, been absorbed by later arrivals, or disappeared through ordinary demographic fragility. A small population can be erased by drought, isolation, disease, bad luck, or simply by being outnumbered over many generations. No single explanation fully accounts for this. The evidence remains incomplete, and it may always remain incomplete, because deep time is not generous with small groups of mobile people. The strange thing is that Homo sapiens are not alone in this world. Beyond Africa, the land is already inhabited. Neanderthals hold much of Western Eurasia, adapted to colder climates, familiar with caves, river valleys, open steppe, and seasonal hardship. Farther east, Denisovans leave a far more mysterious presence, known mostly through DNA and scattered fossils, but likely spread across huge parts of Asia in ways still not fully mapped. There may be other human populations as well. Ghost lineages glimpsed not through skulls in museum drawers, but through odd signals in genomes and puzzling fossils that refuse to sit neatly inside known categories. When early Homo sapiens move outward, they are not entering an empty world. They are entering a human world, but not yet a modern human one. This changes the meaning of disappearance. Some early Homo sapiens groups may have vanished because they blended into others. Genetic exchange between modern humans and Neanderthals is now known to have happened, and not just as a single simple event. There are hints that very early Homo sapiens, or populations close to them, may have carried genes into Neanderthal groups long before the main expansion of modern humans succeeded. If that is true, then some of the lost migrations were not entirely lost. Their descendants may not survive clearly in us, but traces of them may once have passed into the bodies of the humans they met outside Africa. A migration can fail to found a lasting modern population and still alter the history of another human group. That is a quieter kind of success, and a more unsettling one. The old map of human origins begins to look less like an arrow and more like a tide. Waves move out, some break against harsh country, some run far inland, then retreat, some leave pools behind, some merge with other waters. Later waves roll over the marks of earlier ones, not always violently, not always completely, but enough to make the first patterns hard to read. A stone tool found in a cave may record presence without ancestry. A skull may show that people arrived in a region long before their genes became part of the living population. A genome may reveal a meeting that archaeology cannot yet place on a map. Every line of evidence is powerful, but each one speaks in a different language. There is another surprise hidden inside this story. Before Homo sapiens could successfully occupy much of the world, they seem to have widened their own ecological range inside Africa. They were not simply creatures of one landscape, waiting for a road out. By around 70,000 years ago, and perhaps in different ways before that, groups of Homo sapiens are increasingly associated with a broader set of environments. They live near coasts, in grasslands, around lakes, in dry lands, and even in tropical forests once assumed to be difficult for early humans to inhabit. This matters because the world outside Africa is not one world. It is a maze of climates. To survive beyond the familiar, people need more than courage. They need flexible tools, flexible food habits, social memory, mobility, and the ability to read unfamiliar landscapes quickly enough not to be trapped by them. So the great question is not only why some groups left, it is why some did not last, and why later ones did. Perhaps early travellers moved during brief green windows, only to be stranded when those windows closed. Perhaps their numbers were too small. Perhaps they reached places where Neanderthals or Denisovans already held the best territories. Perhaps they survived for a long time but were later absorbed into larger incoming populations, whose descendants carried different genetic signatures. Perhaps the real answer is a combination of all these things, shifting from one region to another, because prehistory rarely offers one clean cause where many messy ones will do. Imagine, then, a camp at the edge of a vanished lake somewhere beyond Africa. The water is real for now. Reeds move in the evening wind. Animals come down to drink. People sit near a controlled fire, repairing tools, sharing food, watching the dark gather over land no human ancestor of theirs had known a few generations before. They are not failures. They are not footnotes. They are living people in a living world. Yet the lake will dry. The path behind them may close. The path ahead may narrow. Their descendants may scatter, merge, or fade until almost nothing remains that can be named with certainty. This is the lost mystery of early human migrations, not a tale of one triumphant march, but of many human presences, some bright for a time, then nearly erased. And the deeper scientists look, the more the silence begins to fill with shadows. Beyond the first doorway, the world does not unfold as a neat road. It opens as a broken geography of chances. To the north and east of Africa, the land changes with a restlessness that modern maps cannot show. The Red Sea narrows and widens with sea level. The Nile feeds corridors of life into lands that may otherwise turn dry. Arabia, often imagined as a timeless desert, becomes something stranger, sometimes a barrier of heat and stone, sometimes a green belt of lakes, rivers, wetlands, and grass. Farther on, the Levant rises like a narrow hinge between continents, a place where Africa, Asia, and the Mediterranean world almost touch. Beyond that hinge stretch the highlands of Iran, the cold plateaus of Central Asia, the steppes of the north, the monsoon forests of the south, the mountains that later people will call the Himalaya, and the Long Island chains leading towards Sahul, the Ice Age continent that joins Australia, New Guinea, and Tasmania into one vast southern world. For early Homo sapiens, none of these names exist. There is no Arabia, no Levant, no Persian Plateau, no Wallacea, no Eurasia. There are only roots and obstacles, remembered water sources, stone outcrops, animal movements, dangerous crossings, familiar plants, unfamiliar tracks, and the knowledge passed from one travelling group to another. A landscape is not a map. It is a memory system. A hill matters because it reveals a valley. A valley matters because it holds water after rain. A dry channel matters because older people remember it flowing once, or because animals still follow it as if water might return. The geography of deep time is built from attention. The great migrations of early humans depend on this changing attention, because the Ice Age world is never simply frozen. It pulses. Cold periods tighten glaciers over northern lands, lower sea levels, expose continental shelves, and shift rainfall belts. Warmer or wetter intervals open corridors through places that later become harsh. A desert can become a grassland without ceasing to be dangerous. A coastline can stretch far beyond the modern shore, offering shellfish, fish, seabirds, freshwater seepage, and raw material, only to disappear beneath the sea when ice melts and oceans rise again. Some of the most important human pathways may now lie underwater, hidden beneath shelves of silt and coral, beyond the reach of ordinary excavation. That is one reason the evidence remains incomplete. The first camps along drowned coasts may have been erased not because people were rare, but because the ocean kept the archive. This changing world creates what researchers often describe as climatic windows. The phrase sounds clean, almost architectural, but the reality is rougher. A climatic window is not a door swinging open for humanity. It is a temporary alignment of rain, vegetation, animals, and tolerable temperatures. It may last long enough for generations to move through it, but not long enough to guarantee that their descendants can move back. In one period, the Sahara and Arabia may hold lakes and grassy corridors. In another, the same regions may dry until scattered groups become separated by distances too large to cross safely. When that happens, a migration does not need a catastrophe to become lost. It only needs connection to fail. The lands outside Africa are already old human territories. Neanderthals are established across much of Western Eurasia, not as crude caricatures, but as skilled people adapted to difficult environments over hundreds of thousands of years. They know cold seasons, caves, river valleys, animal migration routes, and the rhythms of the steppe. Denisovans, still shadowy in physical form, seem to occupy parts of Asia, perhaps widely, perhaps unevenly, leaving genetic traces far beyond the few fossils that can be confidently named. Other archaic groups may persist in corners of the continent, especially in eastern and southeastern Asia, where the fossil record is complex and the categories are still debated. Into this crowded human world, Homo sapiens arrive not as masters of an empty planet, but as newcomers testing the edges of other people's landscapes. The first regions beyond Africa may have been both inviting and treacherous. The Levant, with its caves, valleys, and position between continents, preserves some of the clearest evidence for early modern humans outside Africa. Yet it is also a corridor where populations can appear, disappear, and be replaced across changing climates. A group may enter during a favourable interval, live there for many generations, and then face colder, drier, or more unstable conditions that favour other populations or force retreat. The same land that allows contact also allows turnover. Fossils can tell us someone was there. They cannot always tell us whether that someone became anyone's lasting ancestor. Farther east, Arabia becomes crucial because it is both bridge and filter. In wet phases, it may have offered lakes, rivers, and habitable grasslands across what is now desert. Stone tools scattered in Arabian landscapes suggest repeated human presence. But linking every tool to a specific population is difficult. Some technologies may be shared, convergent, or carried by groups whose bones have not survived. Scholars still debate how many separate movements passed through Arabia, which routes they used, and how many left descendants. What is clearer is that Arabia was not merely an empty stretch to be crossed quickly. At times it was a world in itself, with its own lake shores, hunting grounds, and possibilities for settlement. At other times it became a trap of distance. The Persian Plateau, lying beyond these corridors, adds another layer to the story. It is not only a passage between west and east, it is a high, varied region of mountains, basins, woodlands, grasslands, and refuges, a place where people could pause rather than simply pass through. Recent work has suggested that after a major movement out of Africa, some Homo sapiens populations may have lingered in this broad region for thousands of years before spreading more widely across Eurasia. That idea changes the feeling of the journey. It suggests that the famous expansion of modern humans was not a sprint from Africa to the ends of the earth. It may have included waiting, clustering, adapting, splitting, and slowly building the demographic strength needed to move farther. In deep time, delay can be as important as motion. To the north, the open steppe offers another kind of challenge. It is vast, rich in herd animals, and brutally exposed. A group moving through such country must understand fuel, shelter, wind, seasonal movement, and the danger of distance between resources. To the south and east, tropical forests and monsoon landscapes present the opposite problem. Abundance that is difficult to read, dense vegetation, scattered visibility, different prey, rapid decay of organic remains, and caves where preservation varies wildly. It was once easy to imagine early Homo sapiens as primarily adapted to open savanna or coastal settings, but evidence from Africa itself now complicates that picture. Humans, or populations closely related to them, seem to have used wet tropical forests far earlier than once expected. That matters because it means the skills needed for Asia may have begun forming before the final departure. Then there are the seas. To reach Sahul, people must eventually cross water gaps that remain even when sea level falls. This is one of the most remarkable facts in human migration. Long before cities, writing, farming, or metal, small groups of Homo sapiens find ways to move through island worlds where the next land may not always be visible, and where currents, winds, reefs, and storms matter as much as courage. The evidence for exactly when and how this happened is still debated, but the implication is enormous. Some early people were not only walkers of land corridors, they were coastal foragers, island navigators, and observers of water. All of this turns the world beyond Africa into a maze of temporary permissions. The land allows movement, then blocks it. It offers refuge, then isolates it. It preserves bones in one cave and destroys them in another. It leaves stone tools on dry surfaces while drowning coastal camps beneath the rising seas. The people moving through it are not following destiny. They're making decisions in a world that keeps changing the rules. And somewhere inside that maze, the first lost migrations begin to leave their almost invisible trail. The farther the trail runs from Africa, the more crowded the human world becomes. It is tempting to imagine Homo sapiens as the central figure from the beginning, the species around which all other human stories orbit. But for most of deep time beyond Africa, this is not how the world looks. Across Western Eurasia, Neanderthals have already lived through long cycles of cold and warmth, following animals, shaping stone, using fire, burying or otherwise treating some of their dead in ways that still provoke debate, and adapting their bodies and habits to landscapes where winter is not an interruption, but a force. Farther east, in a darkness that science is still only beginning to light, Denisovans occupy parts of Asia, perhaps mountain corridors, forests, basins, and high plateaus, perhaps places where no confirmed Denisovan bone has yet been found, and beyond them, in the humid and fragmented worlds of island Southeast Asia, other ancient humans may continue their own strange histories, separated by water, forest, and time. This is the human family before the world becomes mostly ours. It is not a ladder. It is not a clean line of improvement. It is a branching, crossing, half-erased web of populations that separate, drift, meet again, exchange genes, vanish locally, and sometimes leave traces in places no one expects. Homo sapiens are part of that web, but not yet its only surviving thread. When early modern humans move out of Africa, they enter a continent already filled with relatives who are different enough to have their own long histories. yet close enough that encounters can leave descendants. That closeness is one of the great surprises of modern genetics. The boundaries between ancient human groups were real, but they were not always walls. The split between the ancestors of Homo sapiens and the ancestors of Neanderthals and Denisovans reaches back hundreds of thousands of years. The exact shape of that split remains debated, partly because fossils do not form a neat sequence and genomes preserve only the populations that happen to leave recoverable signals. A useful picture is this: while the lineage leading toward Homo sapiens develops largely in Africa, the ancestors of Neanderthals and Denisovans expand and diversify across Eurasia. Over time, Western populations become what we call Neanderthals. Eastern populations include the people now called Denisovans, but even that division is too tidy. Neanderthals and Denisovans are sister groups, yet they also exchange genes with one another. Some Denisovan-related ancestry seems to come from a deeply divergent human lineage, suggesting that even they encountered older groups whose names are lost. The deeper one looks, the more every branch seems to contain older shadows. Neanderthals are the better-known relatives because they left more bones. Their heavy brow ridges, large noses, strong bodies, and distinctive skull shapes have made them familiar in museums and documentaries, sometimes too familiar, because familiarity can turn into caricature. They were not failed versions of modern humans. They were a successful Eurasian humanity for a very long time. Their tools change through time. Their diets vary by region. They use fire, hunt large animals, gather plant foods, work hides and wood, and survive in environments that would test any human group. Yet they also live in relatively small, scattered populations, vulnerable to climate instability and local isolation. What survives in the record suggests resilience, not simplicity. Denisovans are different because they were discovered almost backward. They entered science not first as a face, but as a genetic signal. A small bone from Denisova Cave in Siberia, so tiny it could easily have been overlooked, produced DNA unlike both modern humans and Neanderthals. Later, teeth and other fragments added physical hints, but not enough to restore a full body, a full face, or a full way of life. Denisovans are one of the most important ancient human groups ever identified, and yet they remain almost invisible. Their known fossil record is absurdly small compared with the scale of their genetic legacy. A vanished humanity, spread perhaps across enormous distances, is represented by fragments that could fit in a hand. This imbalance between genetic importance and physical scarcity gives Denisovans an almost ghostly role in the migration story. They show that Asia held human populations more varied than archaeology alone had revealed. They also remind us that absence of evidence is not evidence of an empty land. If Denisovans can remain hidden for so long, then other groups may have passed through the record in the same way, leaving signals too faint to name. Some may be known only as ghost populations in genomes, statistical traces of contact with people whose bones have not been found or recognized. The evidence remains incomplete, and in many regions of Asia, preservation itself is an enemy. Heat, humidity, acidic soils, flooding, erosion, and the loss of ancient coastlines have destroyed much of what might have made the story clearer. For early Homo sapiens, meeting these relatives was not a single event. It was a long pattern of possible encounters across thousands of years and many landscapes. A small group moving into the Levant might encounter Neanderthals familiar with the region. A population crossing deeper into Asia might come near Denisovan-related groups whose territories, seasonal routes, or cave sites overlapped with theirs. These meetings could have taken many forms: avoidance, exchange, competition, occasional cooperation, interbreeding, or simply awareness at a distance. Archaeology rarely preserves the social texture of such encounters. A layer of tools cannot easily tell whether two populations feared each other, ignored each other, learned from each other, or slowly merged. Scholars still debate how much cultural exchange occurred between these human groups, and how often similarities in tools reflect contact rather than independent invention. DNA, however, has made one thing impossible to deny. They met closely enough to have children whose descendants carried mixed ancestry. Most people outside Africa today carry some Neanderthal ancestry. Some populations in Oceania, and to lesser degrees parts of Asia, carry Denisovan ancestry as well. These traces are not evenly distributed, which suggests a complex geography of encounters rather than one simple mixing event. The genetic record also hints that Homo sapiens may have moved out of Africa earlier than the main expansion, and contributed ancestry into Neanderthals long before modern humans became widespread in Eurasia. That possibility is especially important for the mystery of lost migrations. A group can disappear from the modern human line and still leave a mark in another human population that later disappears too. In this world, the meaning of identity becomes unstable. A Neanderthal group may carry a trace from an earlier Homo sapiens-related population. A modern human group may carry Neanderthal ancestry from a later meeting. Another population may carry Denisovan ancestry from contact in Asia. But the Denisovan group involved may itself have carried older ancestry from an even deeper lineage. These are not clean species boxes sitting side by side. They are long separated populations with porous edges. And those edges matter. They mean that disappearance is not always replacement. Sometimes it is absorption. Sometimes it is dilution. Sometimes it is survival in a form too scattered for the eye to see. The ancient world beyond Africa is therefore not a stage waiting for Homo sapiens to enter and triumph. It is a layered human continent. Neanderthals hold the west. Denisovans haunt the east. Other archaic groups persist in pockets and islands of survival. Early Homo sapiens move among them in pulses, sometimes finding opportunity, sometimes meeting resistance, sometimes blending at the margins. The later success of our species can make these first movements seem inevitable. But nothing about them was inevitable at the time. The newcomers were few, the landscapes were unstable. The relatives they met had deep experience in those lands. A green corridor could close, a small population could become isolated, a meeting could leave a genetic trace without creating a lasting community. And so the human family splinters, overlaps, and folds back into itself. The lost migrations of Homo sapiens do not happen in emptiness. They happen in a world already human, already ancient, and already full of lives that would one day become difficult to separate from our own. The strangest people in this story are not always the ones with unfamiliar skulls. Sometimes they are the ones who look most like us, carry the same species name, make recognizable tools, use fire, move in social groups, and yet slip away so completely that their descendants cannot be easily found. This is the difficulty of early Homo sapiens outside Africa. They are not mysterious because they are alien. They are mysterious because they are close. A fossil jaw, a few teeth, a skull fragment, a scatter of stone points, or a layer of occupation in a cave may say that modern humans reached a place far earlier than expected. But it may not say whether those people became part of the long ancestry that leads to living populations. Presence is not the same as legacy. A campsite is not a bloodline. A fossil is not a future. For much of the 20th century, the evidence for early modern humans outside Africa seemed to fit a rough pattern. There were old appearances in the Levant, then later, more decisive expansions into Europe, Asia, and beyond. But the details have become increasingly complicated. Modern human fossils appear in Western Asia far earlier than the Great Expansion usually associated with the ancestry of most non-African people today. Some evidence suggests Homo sapiens, or populations very close to them, were present beyond Africa well before 70,000 years ago. There are claims and finds from China and other parts of Asia that point to unexpectedly early modern human presence, though scholars still debate how to interpret some of them. Dating can be difficult. Teeth can be hard to classify. Tools do not always identify their makers. A single discovery can open a door, but the room beyond it may remain dark. This is why the lost migrations of Homo sapiens are so hard to see. Neanderthals have a distinctive fossil form. Denisovans, though physically elusive, have a distinctive genetic signature. Early Homo sapiens are harder in a different way. Their bones may look broadly modern, but modernity itself is not a single clean package. Human anatomy changes gradually, regionally, and unevenly. Some early fossils show a mixture of features. Some are fragmentary. Some come from sites where the dating range is broad. Even when the identification is strong, the question remains, are these people ancestral to later populations? Or are they a branch that reaches outward and then ends? The evidence remains incomplete. And in many cases, the most honest answer is that we do not yet know. A useful image is a shoreline at low tide. For a while, many footprints appear in wet sand. Some cross one another, some move toward the water, some turn inland. Then the tide returns, and most of them vanish. Later, one or two hardened prints survive in a sheltered patch, and from those traces someone tries to reconstruct the movement of an entire crowd. Early migration evidence often feels like this. A cave in the Levant preserves a human jaw or skull. A site in Arabia preserves tools near an ancient lake. A region in East Asia produces teeth that may belong to early modern humans. A European cave yields genomes from people who lived tens of thousands of years ago, but whose lineage seems not to continue clearly into later Europeans. These are not empty hints. They are powerful, but each is a surviving footprint, not the whole beach. The problem becomes sharper when genetics enters the story. If early Homo sapiens were already leaving Africa in multiple pulses, why do living non-African populations mostly trace back to a later expansion? This does not mean every earlier group died immediately. It means that, as far as current genetic evidence can tell, many earlier groups did not contribute substantially to the ancestry of people alive today outside Africa. Their lines may have gone extinct. They may have been absorbed by later Homo sapiens groups whose ancestry became dominant. They may have contributed tiny amounts that are now difficult to distinguish. They may have mixed with Neanderthals or other archaic humans, leaving traces in populations that later vanished themselves. In deep time, genetic disappearance can happen even after centuries or millennia of real life. The early modern humans of Europe offer one of the clearest examples of this unsettling pattern. Some of the earliest Homo sapiens genomes from Europe show people living near the edge of Neanderthal country, carrying Neanderthal ancestry from relatively recent interbreeding events, yet belonging to small and deeply branching populations. They're not simply the first Europeans in a direct sense. They're more like the first visible shadows of modern humans in Europe, groups that arrive early, survive for a time, and then fade from the main ancestry of later populations. This does not make them failures. It makes them pioneers living in a difficult landscape at a difficult moment, when climate, competition, population size, and chance all mattered. Their story is not a straight foundation. It is a brief illumination. In Asia, the picture is even more elusive. The continent is too large. too ecologically varied and too poorly sampled in many ancient periods to allow easy conclusions. Tropical environments destroy DNA. Coastal routes from the Ice Age are now submerged. Many caves have not been excavated, or were excavated before modern dating and genetic methods existed. Some fossils have been lost, damaged, or remain difficult to classify. Stone tools survive better, but stone tools can be deceptive. Similar forms can be made by different people facing similar needs. A sharp flake does not carry a species label. A prepared core does not announce whether the hands that shaped it belong to Homo sapiens, Neanderthals, Denisovans, or another group whose name is still missing. Yet the gaps themselves tell part of the story. If Homo sapiens moved into Asia during earlier windows, they may have done so in small groups spread thinly across enormous regions. Small groups leave small archaeological signatures. They may camp lightly, move often, use organic tools that decay, and bury few traces in places likely to preserve them. A large, stable, growing population can cover a landscape with repeated occupation. A thin pioneer population may vanish archaeologically after leaving only a handful of stones. The absence of dense evidence may reflect fragility rather than absence. What survives in the record suggests that some movements were real, but demographically delicate. There is also the question of identity over time. Imagine a small Homo sapiens group entering a region already occupied by Neanderthals or Denisovan-related people. Over generations, they may interbreed. Their descendants may live culturally closer to one group than another. Their genetic contribution may become scattered. If the population later disappears or merges again, the original migration becomes almost impossible to isolate. Archaeology might find tools but not bodies. Genetics might find a signal but not the campsite where it began. The story becomes blurred at precisely the points where human life was most intimate. This is why the lost early migrations are not merely a side note before the successful expansion. They are the testing ground of human possibility. They show Homo sapiens exploring routes before their species has fully mastered the range of environments that will later define its global spread. They show movement without guarantee, contact without conquest, presence without permanence. They remind us that history is not written only by those who survive clearly. It is also shaped by those who almost did, those who lived on the margins of preservation, those whose existence is known only because a cave held one bone longer than the world held their name. The species with a face, then, becomes a species with missing faces. Early Homo sapiens outside Africa are both familiar and unreachable. They are us, but not exactly our ancestors. They are modern humans, but not necessarily part of the modern human line that endured. Their mystery is not what they were, but where they went after the record briefly caught them in motion. To understand why some migrations vanish, it is necessary to slow down and look at the lives behind the traces, because the people who disappear from genetic history do not disappear from life while they are living it. They wake beside fires that have to be protected through damp nights and windy mornings. They shape stone not as museum objects, but as edges for cutting meat, scraping hides, working wood, opening plants, and solving ordinary problems that return every day. They know where good raw material lies, which stones fracture cleanly, which ones waste effort, and which riverbeds are worth searching after floods. They carry knowledge in bodies and habits how far to travel before heat becomes dangerous, how to read the behavior of birds near water, how to recognize the smell of rain on dry ground, how to keep a group moving without losing the slowest members, how to return to a place that looked empty but held food at the right season. The archaeological record often turns these lives into fragments, because fragments are what survive. A cave floor may preserve ash, stone flakes, animal bones, and the faint pattern of repeated visits. An open-air site beside a vanished lake may preserve tools scattered across old sediments, but little else. A coastal camp may have offered shellfish, fish, plants, birds, and fresh water for generations, then vanished beneath rising seas. A wooden spear, a fibre bag, a digging stick, a woven container, a skin covering, a cord, a trap, a sleeping mat, a memory of a path through reeds, most of these things decay. The ancient world was full of perishable intelligence. What survives in the record suggests competence, but it preserves competence unevenly, often reducing a whole way of life to stone because stone is stubborn enough to outlast almost everything. This matters because the success of Homo sapiens was never only a matter of anatomy. A high forehead, a light skeleton, and a rounded skull do not automatically carry a population across deserts, forests, mountains, and seas. Survival depends on behavior, cooperation, memory, and flexibility. Early migrations likely required small groups to adjust again and again, sometimes within a single lifetime. A plant known in one region may be absent in another. A familiar animal may vanish, replaced by species with different habits. A good hunting strategy in open grassland may fail in woodland. A river crossing may be possible in one season and deadly in another. The world outside Africa asks not one question, but many, and each landscape asks it differently. Inside Africa, long before the later expansion takes hold across Eurasia, Homo sapiens appear to be widening their range. This is one of the most important shifts in the story. The old image of early modern humans as creatures of one preferred environment is fading. Evidence increasingly points to populations using a variety of habitats, including dry lands, coasts, grasslands, and forests. The presence of humans, or humans closely related to Homo sapiens, in wet tropical forests of West Africa around 150,000 years ago is especially striking because such forests were once assumed to be late or difficult environments for our species. Dense rainforest is not an easy supermarket. It can hide animals, scatter edible resources, limit visibility, and quickly destroy traces of occupation. Yet people found ways to live there. That suggests a level of ecological flexibility that would later become crucial. The broader expansion of the human niche may be the quiet engine behind the later success of our species. By around 70,000 years ago, Homo sapiens are not simply waiting for a route out of Africa. They are becoming better at living in different kinds of worlds. They learn to combine foods, move between habitats, use social networks, and maintain knowledge across uncertain landscapes. Scholars still debate exactly how this process unfolded, and it should not be imagined as one sudden invention or one clever trick. It is more likely a slow accumulation of habits, technologies, and relationships, changing from region to region. But the result is profound. A species that can live in many environments is harder to trap when climate changes. A population that can shift its diet is less vulnerable when one resource fails. A network that can exchange information across distance can survive uncertainty better than an isolated band. The earlier migrants beyond Africa may not yet have had the same combination of numbers, networks, and ecological range. This does not mean they lacked intelligence or skill. It means they may have moved under narrower conditions. If a group leaves during a wet interval and depends heavily on a chain of lakes and grasslands, then the drying of that corridor can isolate them. If they enter a region where food is seasonal and unfamiliar, they may need generations to adapt. If their population remains small, every local problem becomes larger. A failed hunt, a broken connection with neighbouring groups, a dry year, a blocked route, a lost source of stone, a shift in animal movement. Any one of these might be manageable for a large connected population, but dangerous for a small scattered one. No single explanation fully accounts for the disappearance of early migrations, but demographic fragility gives the mystery a human scale. Daily life also shapes what can be inherited. Skills do not move automatically through space. They depend on teaching, observation, practice, and social continuity. A technique for making a particular kind of stone tool can survive only if enough learners remain connected to enough skilled makers. Knowledge of a distant waterhole matters only if someone remembers the route and returns at the right time. Seasonal movement is a cultural map written in experience. When groups become isolated, knowledge can narrow. When groups meet, knowledge can expand. The difference may decide whether a population merely survives for a while or grows strong enough to endure across millennia. There is a quiet drama in this because most of the decisions that shaped human migration were probably ordinary. A group follows animals toward a greener valley. A family stays near a lake one season longer than expected. A band returns to a cave because the wind is less severe there. People move along a coast because shellfish can be gathered reliably, or climb into highlands because dry lowlands no longer support them. They do not know they are part of a dispersal event. They do not know future scientists will ask whether their migration failed. They are simply trying to keep life continuous. And yet, in that continuity, the difference between a lost migration and an enduring one begins to form. The later expansion of Homo sapiens seems to carry something more than movement larger networks, broader ecological confidence, perhaps stronger links between distant groups, and a capacity to enter landscapes that had defeated or isolated earlier travellers. The first pioneers beyond Africa may have known some doors. The later populations seem to have learned how to survive when the doors close behind them. The fragments left behind cannot show every gesture or every path. They cannot restore the smell of smoke in a cave, the patience of tool-making, the careful division of food, the remembered shape of a valley after rain. But they do show that these people were not shadows drifting through empty terrain. They were skilled, alert, adaptive humans living full lives at the edge of possibility. Their tragedy, if it can be called that, is not that they did not know how to live. It is that living for a time is not the same as leaving a lasting trace. The long roads across Asia begin with the strange pause. It is tempting to picture Homo sapiens leaving Africa and spreading outward like sparks from a fire. But the evidence now suggests something slower, more uneven, and more human. A major movement may have carried people beyond Africa, tens of thousands of years before they become widely visible across Eurasia. Then, instead of racing immediately to every horizon, some populations may have gathered, lingered, and adapted in the broad lands of Southwest Asia, especially the region around the Persian Plateau. This was not a waiting room in the simple sense. It was a world of mountains, basins, valleys, woodlands, grasslands, and refuges, where people could remain connected while learning the geography that later opened into the rest of the continent. That pause matters because it changes the emotional shape of the migration. It may have included a long middle act, a time when small populations became larger, when groups exchanged partners, tools, and knowledge, when people learned how to live at the edge of deserts, highlands, cold seasons, and unfamiliar animals. The Persian Plateau could have acted as a hub, not because every person passed through one exact point, but because the region sits between worlds. To the west are the Levant and Arabia. To the east are Central Asia and South Asia. To the north lie colder corridors toward the Caucasus and steppe. To the south are routes toward the Indian Ocean and coastal margins. In a changing Ice Age world, a hub is not a city or a capital. It is a living knot of landscapes. From such knots, movement can happen in many directions. One path bends north and west toward the Caucasus and Europe, where some early Homo sapiens appear as small pioneer populations close to Neanderthal territory. Another path runs eastward across Iran and into Central Asia, where mountains, deserts, and river valleys break the land into passages and traps. Another turns south toward the Indian subcontinent, a region with monsoon rhythms, coasts, forests, dry zones, and stone tool traditions that are still difficult to link neatly with particular populations. Farther east, the routes divide toward mainland Southeast Asia, southern China, island chains, and eventually the threshold of Sahul. Asia is not one corridor. It is a continent of corridors, each with its own timing and dangers. The coastal route has always had a powerful attraction in the story of human expansion. It is easy to picture people moving along shorelines, gathering shellfish, fishing in tidal pools, following freshwater sources, and using the sea as a guide. There may be truth in this, but the record is difficult because Ice Age shorelines are often not modern shorelines. When sea levels were lower, the coast could lie far beyond today's beaches, across plains now submerged. Camps that once stood near estuaries or lagoons may be buried beneath the ocean. This loss can make early movement seem more sudden than it was. Inland routes are just as important, though less romantic. Rivers, lake basins, grassland pockets, and mountain foothills could pull people across enormous distances. During wetter phases, Arabia and parts of Southwest Asia may have contained lakes and green corridors that allowed movement deeper into the continent. During drier phases, those same regions could break populations apart. A group that once moved freely from water to water might later find the chain broken if contact fails. Small communities can become isolated. They may survive for generations, even beautifully, but their long-term future becomes fragile. Migration depended on timing as much as desire. The first modern humans who reached Eastern Asia may have encountered worlds very different from the dry passages behind them. Forests, river systems, limestone caves, monsoon climates, and older human populations all complicate the picture. Some fossil and archaeological evidence suggests early modern human presence in parts of Asia, long before the later widespread expansion becomes obvious, though the interpretation of some sites remains debated. Teeth may look modern but lack DNA. Tools may show human skill but not identify the species of their makers. In humid regions, bones decay quickly and ancient DNA often disappears. The result is a continent filled with hints, some strong, some disputed, some waiting for better methods. Southeast Asia sharpens the mystery because it is a region of both passage and disappearance. During low sea levels, large parts of the Sunda Shelf were exposed, joining much of mainland Southeast Asia with islands that are separate today. Rivers crossed open plains where seas now lie, forests shifted, coasts moved outward, yet even at the lowest sea levels, some water crossings remained. To reach Sahul, people had to move through Wallacea, a zone of islands, currents, and uncertain horizons. This required planning, observation, and some form of water travel, even if the vessels themselves have vanished without a trace. Organic boats do not survive well across tens of thousands of years. What remains is the fact of arrival. The settlement of Sahul carries a special weight because it shows how far Homo sapiens could go before farming, metal, writing, or states. People reached a southern continent filled with animals, plants, and seasons unlike those of Africa or Southwest Asia. But even here, the timing and routes are debated. Some genetic work supports a long chronology, placing the arrival of modern humans in Sahul around 60,000 years ago, perhaps by more than one pathway. Archaeological sequences in the islands near Sahul can also reveal surprising patterns. At Leyte in Timor-Leste, evidence points to an abrupt intensification of occupation around 44,000 years ago. That does not necessarily mean no humans ever passed nearby before. It may mean that a later wave became more visible, more numerous, or more firmly rooted, while earlier movements left fewer traces or were overtaken by populations that came after. This idea, that later waves can cover earlier footprints, is essential. Human expansion is not like ink spreading evenly on paper. It is more like smoke moving through broken rooms, thick in some places, invisible in others, changing with every draft. An early population may reach a region, live there for thousands of years, and then become absorbed by a later population with more people or wider connections. Their tools may be replaced. Their genetic contribution may be diluted. Their camps may be buried, eroded, or drowned. Later descendants may carry only tiny fragments, or none that can be detected. When scientists say an early dispersal left no clear genetic contribution to present-day non-Africans, it does not mean the people were imaginary. It means the thread is no longer visible in the tapestry we can currently examine. Across Asia, then, the roads are long not only in distance but in consequence. Some lead to lasting settlement, some lead to meetings with Neanderthals, Denisovans, or other groups. Some lead into refuges where people wait through harsh intervals. Some lead to regions where the evidence has been destroyed by climate and sea. The lost migrations may not form one story, but many a group isolated in a drying interior, another absorbed along a river corridor, another leaving traces in an archaic population, another moving along a coast now underwater, another replaced by later arrivals at the edge of Sahul. Still, the roads continue eastward, northward, and southward. The next layer of the mystery lies not simply in how far people moved, but in how their bodies and descendants changed when they entered places where cold, altitude, and thin air tested the limits of being human. Cold changes the meaning of distance. In warm country, a valley may be far because it takes time to cross. In cold country, a valley may be far because the wind can strip heat from a body before the far slope is reached. Altitude changes distance again. A ridge that looks close can become exhausting when the air thins, when each breath brings less oxygen, when water freezes in shadow and fuel is scarce above the tree line. For Homo sapiens moving deeper into Eurasia, the challenge is not only how to travel across the map, it is how to remain human in places where the body itself begins to argue with the landscape. The Ice Age world is not a single cold world. It is a patchwork of cold, dry, wet, wooded, open, glaciated, windswept, and seasonally generous places. But as people move northward and eastward from Southwest Asia, the demands multiply. Nights grow longer and sharper. Animals carry more fat in some seasons and vanish in others. Plants become more seasonal. Shelter matters more. Fire becomes not just useful, but central. Clothing, hides, bedding, windbreaks. And the control of heat become part of survival in ways that leave few direct traces. A stone scraper may survive. The hide it helped prepare usually does not. A hearth may survive. The careful social knowledge of keeping fuel dry through bad weather does not. Yet without those perishable skills, the long roads into colder Asia would have narrowed quickly. For the early groups whose migrations later vanish from clear ancestry, harsh environments would have amplified every weakness in the chain of survival. A small population can endure mild country with more room for error. In cold or high places, error becomes expensive. A missed season, a failed connection with neighbouring groups, a shortage of fuel, or an unfamiliar winter pattern may reduce a community's chances over generations. This is not a dramatic collapse. It is pressure. It is the slow tightening of limits. The evidence remains incomplete, but it is reasonable to suspect that some early expansions reach the margins of difficult environments before their social networks and ecological flexibility were strong enough to hold them there permanently. And yet, humans did not simply avoid such places. One of the most remarkable developments in the story of ancient humanity is that different human groups learn to live under conditions once imagined too severe for deep prehistory. Neanderthals were long adapted to colder Eurasian environments. Denisovans, shadowy though they remain, may have occupied regions ranging from Siberian caves to high-altitude landscapes. Homo sapiens eventually spread through many of these same worlds. But the timing and success of that spread varied. It is one thing to enter a cold corridor during a favourable season. It is another to return, reproduce, teach, remember, and become established there. Denisovans bring the clearest surprise. For decades, high-altitude adaptation seemed like a modern human achievement belonging mostly to recent populations living on the Tibetan Plateau and nearby regions. Then ancient DNA changed the picture. A version of a gene involved in oxygen response, often discussed in connection with Tibetan high-altitude adaptation, appears to have come from Denisovan-related ancestry. The exact pathways and timing remain debated, but the implication is extraordinary. A vanished human group, known mostly from fragments, helped some modern humans inherit a biological advantage for living where the air is thin. The people themselves disappear as a recognizable population, yet a piece of their adaptation remains active in living bodies. This is one of the most powerful examples of disappearance without total loss. The Denisovans are gone as a people we can point to in the present, but not everything Denisovan vanished. Their legacy survives in genes affecting altitude, immunity, and other traits in different populations. For a script about lost Homo sapiens migrations, this matters because it widens the meaning of survival. If Denisovans can disappear yet continue through fragments of inheritance, then early Homo sapiens groups may also have left traces in indirect ways in Neanderthal genomes, in diluted ancestry, in cultural habits too faint to identify, or in later populations whose genetic signals have been blurred by time. Disappearance is often not a clean erasure, it is a scattering. The highlands themselves are archives of stress. On the Tibetan Plateau, the combination of altitude, cold, strong radiation, and limited resources makes permanent life difficult even for people with deep cultural knowledge. Yet archaeological and genetic evidence increasingly suggests that archaic humans and later modern humans moved through or occupied high places earlier than once assumed. The famous Siahi mandible from Baishia Karst cave, linked to Denisovans through protein evidence, places a Denisovan-related human presence on the northeastern Tibetan Plateau long before the modern period. Later sediment DNA from the cave deepened the sense that Denisovans were not confined to one Siberian chamber, but part of a wider Asian story. Scholars still debate their exact range, appearance, and culture, but they were clearly not just a curiosity from Denisova cave. For Homo sapiens, Such landscapes would have been both barrier and invitation. Highlands can block movement, but they can also preserve refuges. Valleys between mountains may hold animals, water, wood, and stone. Plateaus can connect distant regions if people know how to move through them. During climate shifts, highlands may become shelters from lowland heat or corridors between basins, but they also isolate. A group living in one mountain system may lose contact with others when routes become impassable. Isolation can protect traditions, but it can also shrink choices. In the long run, small isolated populations are more vulnerable to chance. Cold steppe landscapes pose a different problem. They can be rich with herd animals, but the richness moves. People must follow seasonal patterns, understand animal behavior, and plan around scarcity. Open landscapes also expose human groups to visibility, wind, and distance. A cave or rock shelter becomes valuable not because people live permanently inside darkness, but because it offers repeated protection within a larger seasonal range. Some of the most important ancient sites are caves because caves preserve evidence, not necessarily because caves define all of life. The people who used them lived across broader territories, moving through open air, river margins, forest edges, and hunting grounds that left far less behind. This uneven preservation can distort the story. Denisova Cave becomes famous because it preserves bones and DNA, but Denisovans were not cave spirits. Neanderthals appear often in limestone shelters because limestone shelters preserve them. Early Homo sapiens may seem absent from regions where their camps were open air, coastal, or made of materials that vanished. The map of discovery is not the same as the map of life. What survives is shaped by geology, chemistry, excavation history, and luck. Still, the pattern is clear enough to feel the pressure building. The later success of Homo sapiens across Eurasia required more than a route out of Africa. It required the ability to live across extreme contrasts, deserts and forests, coasts and inland basins, lowlands and mountains, heat and cold, familiar and unfamiliar food webs. The broadening of the human niche before the main dispersal becomes crucial here. A species already practicing flexibility has a better chance when thrown into the maze of Eurasia. Earlier migrants may have had some of that flexibility, but perhaps not enough population density, not enough connected networks, or not enough time. The wind over a plateau leaves almost nothing behind. It does not preserve footsteps for long. It scours camps, buries tools, erodes bone, and turns living places into scattered clues. Yet in the bodies of living people, in a jaw from a high cave, in DNA from sediment, and in the faint roots through ice-age landscapes, something remains. The ancient human story is not only about who reached the farthest place, it is about who could stay, who could adapt, who could merge, and who became a trace carried silently forward by others. By the time Homo sapiens enter the maze in larger numbers, the world has already tested earlier travellers and hidden much of what happened to them. The deserts have opened and closed, the coastlines have moved, the highlands have offered refuge and isolation in the same breath. Neanderthals remain in the west, Denisovan-related groups haunt the east, and the paths between them are not clean highways but shifting corridors of climate, water, animals, and memory. Into this unstable geography come modern humans whose descendants will eventually spread across almost every habitable region of the planet. Yet even this later movement is not simple. It does not begin as a triumphant march. It begins as another uncertain presence in a world that has already swallowed human footsteps before. The timing is one of the great questions. Many lines of evidence suggest that the main ancestry of most people outside Africa today traces back to a population that expanded after earlier unsuccessful or lost movements. Genetic estimates vary, and different studies emphasize different windows, but a broad picture has taken shape. Homo sapiens leave Africa in more than one pulse. And the movement that becomes dominant outside Africa likely follows a period of growing ecological flexibility within Africa and possible consolidation somewhere in Southwest Asia. They may pass through Arabia during favourable intervals. They may linger around the Persian Plateau. They may not appear widely across Eurasia until tens of thousands of years after the first steps beyond Africa. That delay is not empty time. It is the hidden middle of the story. The idea of a Persian Plateau hub gives this hidden middle a landscape. It suggests that after moving out of Africa, some Homo sapiens populations may have remained for a long period in a broad region where different routes met. There, they could grow, split, reconnect, and adapt before spreading west into Europe, east across Asia, and south toward the Indian Ocean routes. This does not mean every group sat still in one place, as if waiting for a signal. It means the expansion may have required a demographic and ecological base, enough people, enough exchange, enough knowledge, and enough flexibility to make later dispersal durable. A small pioneer group can vanish. A larger network can endure the closing of one route because another remains known. This is where the later Homo sapiens differ from some of the earlier shadows. They seem to arrive with broader capacities for living across different environments, capacities that were developing within Africa before the Great Expansion. The ability to use coasts, forests, drylands, grasslands, and mixed habitats matters because Eurasia is not one challenge. It is a sequence of changing tests. In one region, success depends on following herds across open country. In another, it depends on reading monsoon forests. In another, it depends on using rivers and lakes that may not last. In another, it depends on surviving cold seasons among people who already know the land. No single invention explains this. The evidence suggests cumulative flexibility rather than a sudden miracle. Still, even the later expansion produces branches that fade. Europe preserves some of the most haunting examples because ancient DNA can sometimes be recovered there. The earliest modern human genomes from sites such as Raenis and Zlati Kun show people living around 42 to 49,000 years ago, close in time to Neanderthal encounters, yet belonging to small, deeply branching populations. They are Homo sapiens, but they are not simply the direct beginning of later European ancestry. They stand near the edge of a transformation, visible for a moment, then largely gone from the later genetic landscape. It is difficult not to imagine them as first lanterns carried into a cold room, real, bright, and then extinguished or overtaken by other lights. Their world is not gentle. Europe during this period is a land of shifting climates, open steppe, forests that advance and retreat, cave systems, river valleys, large animals, and Neanderthal populations whose own future is narrowing. Homo sapiens moving into this region may not be numerous. They may arrive in small groups, perhaps following animals, perhaps moving through corridors opened by climate, perhaps connected to larger populations farther south or east. But if those connections break, their survival becomes precarious. A lineage can branch early and then end without leaving a strong mark in later people. What survives in the record suggests presence, contact, and movement, but not permanence. Asia likely held even more such stories, though fewer have been recovered clearly. The land is larger, the climate's more destructive to DNA, and the ancient coastlines often drowned. modern human groups may have moved through South Asia, Central Asia, southern China, Southeast Asia, and island worlds in pulses that we can only partly detect. Some may have followed coasts now submerged. Some may have moved through river corridors now altered beyond recognition. Some may have entered forests where bone preservation is poor. Some may have reached island thresholds, leaving traces later obscured by new waves of occupation. Scholars still debate the timing of many early Asian finds, not because the story is unimportant, but because the evidence is fragmentary and often difficult to classify. The threshold of Sahul shows how sudden visibility can be deceptive. Humans may have reached the greater Australia-New Guinea landmass around 60,000 years ago, according to some genetic interpretations, possibly by more than one route. Yet archaeological sequences in the islands leading towards Sahul can show sudden intensification much later in certain places. At Leyli in Timor-Leste, the record suggests a striking increase in occupation around 44,000 years ago after earlier gaps. This may reflect a new wave, a more settled presence, a population increase, or a route becoming more important. It also warns against assuming that the first detectable intensive occupation is the first human movement. A faint crossing can precede a visible settlement by thousands of years. The maze also contains vanished corridors. During lower sea levels, lands now separated by water were connected into broad plains. Sunda, the exposed shelf of Southeast Asia, would have offered river systems, coastal margins, forests, and open areas that no longer exist above water. People could have moved through landscapes that are now under the sea, leaving behind almost no accessible record. When later sea levels rose, entire migration archives drowned. The same may be true along parts of the Indian Ocean coastline, the Red Sea, and other shorelines. The absence of camps in these places may say more about the sea than about human absence. For the people living through these movements, the maze is not a puzzle to be solved once. It changes as they move. A route known to one generation may fail for the next. A lake may shrink. A coast may shift. A neighbouring group may vanish, taking with it knowledge of a distant valley. Another group may arrive, bringing new tools, new partners, new memories, and new risks. The story of Homo sapiens entering Eurasia is therefore not only a story of expansion, it is a story of sorting, which branches remain connected, which become isolated, which merge, which are replaced, and which leave only enough evidence to prove that they once existed. This is the deeper meaning of the lost migrations. Homo sapiens do not become global because every journey succeeds. They become global after many journeys, some forgotten, some absorbed, some overwritten by later descendants who carry different genetic signatures. The maze does not reward being first. It rewards endurance, connection, adaptation, and luck. And as modern humans move farther into lands already occupied by other kinds of humans, the next layer of the story begins to write itself not only in tools and bones, but in bloodlines. The next archive is not a cave, not a lake bed, not a buried shoreline, but the body itself, long after hearths go cold and camps vanish under silt. Fragments of ancient meetings can remain in DNA, copied from generation to generation, until they become almost invisible parts of living inheritance. For most of history, no one could read that archive. Bones could be compared, tools classified, caves excavated, and landscapes reconstructed. But the intimate fact of who met whom, and what those meetings meant for ancestry, remained mostly beyond reach. Then ancient genetics opened a door that archaeology alone could not open. It showed that the human world beyond Africa was not only a world of neighbouring populations, it was a world of contact. The first great shock was Neanderthal ancestry in living people outside Africa. The old replacement story had imagined Homo sapiens leaving Africa and simply taking the place of archaic humans. But DNA made that version too clean. Most non-African people today carry a small percentage of Neanderthal ancestry. Not enough to make Neanderthals simply us, but enough to prove that modern humans and Neanderthals met closely and left descendants. Later work made the picture even more complex. The mixing was not necessarily one brief moment at one place on the map. It appears to have involved a period of contact, perhaps occurring in more than one region, as Homo sapiens moved through Southwest Asia and into Eurasia. Scholars still debate the exact timing, geography, and number of events, but the old wall between species has become porous. This has enormous consequences for the mystery of lost migrations. If living people carry Neanderthal ancestry from encounters during the main expansion, then older Homo sapiens movements might also have left genetic traces, but not necessarily in us. Some studies suggest that gene flow may have gone from early Homo sapiens or Homo sapiens-related groups into Neanderthals long before the main modern human expansion became successful. That possibility feels almost like a message from a vanished expedition. Imagine a population leaving Africa very early, reaching Western Eurasia, meeting Neanderthals, and eventually disappearing as a separate modern human lineage. Their own descendants may not survive clearly in living Homo sapiens today, but a trace of them may have entered Neanderthal populations, remaining there for tens of thousands of years before Neanderthals themselves vanished as a distinct people. It is a migration lost twice over, and yet not entirely erased. This is why ancestry can be stranger than geography. A group may move far, fail to establish a lasting population, and still change the genome of another human group. Later, when that other group mixes again with incoming Homo sapiens, fragments of old contact may be carried forward in unexpected ways, tangled with later ancestry until the original event becomes difficult to separate. DNA does not preserve a simple family tree. It preserves a braided river, with channels splitting, rejoining, drying and leaving traces in sediments far downstream. What survives in the record suggests not one clean out of Africa event, but repeated movements and repeated meetings, some large enough to shape living ancestry, others faint enough to appear only through careful statistical shadows. The Denisovan story deepens the pattern. Denisovan ancestry is not distributed evenly across the world. It is especially significant in parts of Oceania and present in lower levels across parts of Asia, suggesting that Homo sapiens encountered Denisovan-related groups somewhere east of the Neanderthal heartlands, perhaps more than once. The difficulty is that Denisovans are physically elusive. Their known fossils are few, yet their genetic legacy is widespread enough to imply a far larger range than the fossil record alone would suggest. This is one of the great warnings of ancient human history. The bones we have are not proportional to the lives that were lived. A population can be nearly invisible in the ground and still leave a powerful mark in the bloodlines of others. For Homo sapiens moving through Asia, encounters with Denisovan-related groups may have happened in landscapes that are now hard to recover: highland caves, forest margins, river corridors, drowned coastal plains, island thresholds, or interior refugees. The exact places remain debated. Some Denisovan ancestry in modern populations may come from deeply separated Denisovan groups, rather than a single uniform population. This means Denisovan may be less a single neat people, and more a label for a range of related populations spread across Asia over long periods. If that is true, then Homo sapiens did not meet one Denisovan world. They met pieces of a vast, older human geography, perhaps at different times, in different regions, under different conditions. The meetings themselves should not be imagined too narrowly. Ancient interbreeding was not an event marked by banners and boundaries. It likely occurred in small human settings groups overlapping at resource zones, neighbouring bands becoming familiar over time, individuals moving between communities, populations merging at their margins. Some contact may have been rare, some may have lasted generations. Some may have produced ancestry that endured because descendants became part of expanding Homo sapiens networks. Other contact may have left no detectable descendants at all. The evidence remains incomplete, and genetics can reveal that meetings happened without restoring the social world in which they happened. Even so, the consequences are visible. Some inherited archaic variants appear to have affected immunity, skin, metabolism, adaptation to altitude, and other traits, though not every ancient fragment is beneficial and not every association is simple. The Denisovan-related contribution to high-altitude adaptation in Tibetan populations is one of the clearest examples of a vanished population helping living humans endure a difficult environment. More recent work continues to explore how Denisovan DNA influences immune systems in Oceanians, showing that an extinct human group can remain biologically active in people today. This is not survival in the ordinary sense. It is survival as function, as a borrowed tool carried inside the genome. There is a quiet irony here. The early Homo sapiens groups that vanish from clear ancestry are often treated as failed dispersals, while Neanderthals and Denisovans are treated as extinct relatives. Yet all three categories blur. Some early Homo sapiens may have lived outside Africa without founding lasting modern populations, but they may have contributed genes to archaic humans. Neanderthals disappeared as a distinct population, but part of them persists in many living humans. Denisovans are almost absent as fossils, yet their genes still shape adaptation and immunity. The word vanished begins to lose its sharp edge. In deep prehistory, a people can vanish from the landscape, vanish from culture, vanish from recognizable bones, and still remain a scattered inheritance. This also complicates any simple story of conquest. Popular imagination often wants one human group to defeat another in a clean drama of superiority. The evidence does not support such a simple picture. Competition may have mattered in some places. Climate stress, disease, population size, resource pressure, and social networks may have mattered as well. But interbreeding shows that contact was not only replacement from a distance, it included incorporation. Some boundaries dissolved. Some lineages entered others. Some disappearances were partly absorptions. No single explanation fully accounts for the patterns, and the patterns themselves differ from region to region. The bloodline archive therefore gives the lost migrations a second life. It tells us that the first journeys out of Africa may not have ended simply because a group vanished from our direct ancestry. Some became part of other human histories. Some left traces in genomes that later faded. Some were overwritten by larger expansions. Some may still be hidden in signals too subtle to isolate. The story of early Homo sapiens outside Africa is not just a story of where people walked. It is a story of who they met, who they became entangled with, and how a vanished path can remain inside another people's future. The vanishing migration puzzle begins with a contradiction that sounds simple until it is followed into the dark. Fossils and tools suggest that Homo sapiens, or people very close to Homo sapiens, reached lands beyond Africa earlier than the great expansion that eventually gave rise to most living non-African ancestry. Yet the genomes of people alive today do not clearly descend from many of those early ventures. The footprints are there, but the family tree does not always follow them. The camps appear, the bones appear, the roots seem possible, and then the line fades. It is this gap between presence and ancestry that gives the story its uneasy power. Human beings reached beyond the familiar world, and then, in some way, history stopped carrying them forward. The first mistake is to imagine these migrations as simple failures. A group that survives for 10 generations beyond Africa has not failed in any human sense. A group that lasts for 1,000 years in the Levant, Arabia, or parts of Asia has not failed because it does not appear in a modern genome test. They may have known the land, adapted to seasonal resources, raised children safely within their communities, shaped tools, used fire, cared for one another, and told stories under skies their African ancestors had never seen. The word failure belongs more to the scientist looking backward through ancestry than to the people living forward through time. Some researchers have suggested that these early dispersals are better understood as lost migrations rather than failed ones. That small change in language matters because it restores the reality of lives that did not become dominant. Climate is one of the great forces behind the puzzle. Across the last 300,000 years, the Sahara and Arabia did not remain fixed deserts. At intervals, rainfall increased, lakes formed, rivers ran, grasslands spread, and animals moved through regions that later became nearly impassable. These wetter phases could allow Homo sapiens to move northward and eastward, following resources rather than crossing a lifeless barrier. But the same system that opened the road could close it again. When rainfall belts shifted, lakes shrank. When grasslands retreated, herds moved or disappeared. What had been a chain of living places could become a broken necklace of dry basins and dangerous distances. A group beyond the corridor might find itself cut off from the populations behind it. Once isolated, it had to survive not only the land ahead, but the loss of connection behind. Isolation is quieter than disaster, but often more decisive. Small populations are vulnerable in ways large populations are not. They can lose genetic diversity. They can lose cultural knowledge if too few skilled people remain. They can become trapped between unsuitable habitats. They can fail to find neighbouring groups for exchange, marriage, or cooperation. A bad climatic interval does not need to kill everyone at once. It can simply reduce numbers, break networks, and make recovery harder with each generation. No single explanation fully accounts for the disappearance of early Homo sapiens movements, but demography is one of the most powerful invisible forces. A population can be intelligent, skilled, and adaptable, yet still too small to survive repeated shocks. The Levant shows how a doorway can also be a revolving door. It lies close enough to Africa to receive early Homo sapiens during favourable windows, but it also sits near regions long used by Neanderthals. Across changing climates, different populations may have occupied the same caves and valleys at different times. Modern humans appear, then Neanderthals appear, then later modern humans return. This does not require a simple battle or replacement scene. It may reflect climate-driven range shifts, changing habitats, different adaptations, and the unstable position of the Levant itself. It is a threshold, and thresholds are rarely peaceful in the geological sense. They are places where worlds meet, where movement is easy when conditions align, and where populations may withdraw or vanish when the alignment breaks. Arabia adds a wider version of the same problem. During green intervals, it could hold lakes and wetlands that made movement possible. During dry intervals, it could fragment into harsh country, where only certain routes remained viable. Stone tools from ancient Arabian landscapes reveal repeated human use, but they do not always tell us who made them or whether those people continued into later populations. A tool beside an ancient lake may represent a successful local life and a lost long-term lineage at the same time. The surprising detail is that some of the most important roads in human history may have existed only intermittently. They were not permanent highways, but temporary ecological invitations. People walked through them because they were real. Later, they disappeared so completely that the modern eye sees only desert and assumes the road was never there. Competition with other humans may also have shaped the puzzle, though it must be handled carefully. Neanderthals and Denisovans were not background obstacles waiting to be removed. They were experienced populations with deep knowledge of Eurasian environments. Early Homo sapiens entering their territories may have faced competition for hunting grounds, shelters, stone sources, and seasonal routes. But competition does not have to mean constant conflict. It can mean that the best refugees are already known by others. It can mean that a newcomer group cannot expand quickly because another human population is already established. It can mean avoidance, limited contact, occasional exchange, or absorption. Scholars still debate how often direct competition mattered compared with climate and demography, and the answer likely differed by region. Absorption may be the most haunting possibility because it leaves the least dramatic ending. A small Homo sapiens group beyond Africa meets Neanderthals, Denisovans, or another modern human population arriving later. Over generations, boundaries soften, people move between groups, children inherit mixed ancestry, tools and habits change. The original group ceases to exist as a separate population, not because everyone dies, but because their descendants belong to something else. If their genetic contribution is small, it may become difficult to detect tens of thousands of years later. This kind of disappearance is not extinction in the simple sense. It is blending, dilution, and transformation. It is a river entering a larger river and losing its name. Later Homo sapiens waves could also have overwritten earlier ones. A small pioneer population may leave Africa, reach Asia, survive for a long time, and then encounter a larger, better connected expansion from the same species. The later group may carry broader ecological skills, stronger social networks, or simply more people. Over many generations, the later ancestry becomes dominant. The first population is absorbed or replaced locally, and its genetic signal fades below visibility. This may help explain why early traces can appear in the archaeological record without becoming major contributors to living ancestry. Being first is not the same as becoming foundational. In prehistory, the first arrival may be the one most exposed to uncertainty. Chance also deserves a place, though it is often unsatisfying. Science seeks patterns, and rightly so. But small human populations are deeply vulnerable to chance. A drought lasting a few years, a disease moving through a connected region, the collapse of a key animal population, a volcanic winter far away that alters rainfall, a route blocked by conflict or climate, a sequence of poor seasons at exactly the wrong time, all could redirect ancestry. The evidence remains incomplete. And chance leaves few clear signatures. It rarely announces itself in a sediment layer. It simply changes which groups are numerous enough to be sampled by the future. The deeper pattern is that early Homo sapiens migrations were caught between opportunity and fragility. Climate opened windows, but windows closed. Other humans offered contact, but also competition and absorption. New lands offered resources, but also unfamiliar risks. Small groups could move astonishing distances, yet distance itself could weaken the networks that made survival durable. The later expansion, after the broadening of the human niche, appears to have carried a stronger capacity for persistence across varied environments. Earlier groups may have crossed the threshold before those capacities were widespread enough, or before their populations were large enough to turn movement into permanence. So the vanishing of early Homo sapiens is not one event. It is a pattern made from many endings: local extinction, retreat, absorption, replacement, isolation, genetic dilution, drowned coastlines, closed deserts, and lost evidence. The mystery survives because each trace proves that people were there, while the wider ancestry often refuses to carry them forward clearly. They are present in the ground and absent in the lineage, visible as travellers and invisible as ancestors. Their story is the shadow side of human expansion, the reminder that the road to a populated world was lined with paths that did not continue. The places that preserve the next clues often feel almost too small for the size of the mystery they hold. A cave chamber, a tooth, a sliver of skull, a fingertip of bone, a layer of sediment no thicker than a hand. Human history, at this depth, does not usually arrive as a grand ruin. It arrives as fragments that ask more than they answer. Across Asia, from the Levant to Siberia, from the Tibetan Plateau to southern China and the island routes towards Sahul. The record is filled with such fragments, pieces of people, traces of occupation, hints of ancestry, and genetic shadows that suggest whole populations once existed, where no complete skeleton stands waiting to explain them. Denisovan Cave remains the most famous reminder of how much can be hidden in something small. In the Altai Mountains of Siberia, a place that might once have seemed important, mainly for its archaeological layers, became the doorway to an unknown humanity. A bone fragment, at first visually unremarkable, yielded DNA that did not belong neatly to Neanderthals or modern humans. From that small discovery came Denisovans, a group now central to understanding Asia. Even though their physical remains are still scarce, the cave itself also preserves evidence of different human relatives in the broader region, making it less like a home of one people than a crossroads used across deep time. It is difficult to imagine a clearer warning the human past contains populations that can remain invisible until a molecule speaks. The warning applies to Homo sapiens as well. Early modern human traces in Asia are scattered unevenly and often come from difficult evidence. A jaw in the Levant can reveal a presence far earlier than the main expansion. Teeth from caves in China may suggest early modern humans deep in East Asia, though scholars still debate the dating, classification, and meaning of some finds. Fossils from Southeast Asian caves show modern humans moving through tropical and mountainous worlds. But preservation is patchy and DNA rarely survives in such heat and humidity. In some places, anatomy says one thing, tools say another, and genetics is absent entirely. The evidence remains incomplete, not because the story is thin, but because the archive is damaged. Teeth are especially strange witnesses. They are small, durable, and deeply informative, but they are not always easy to interpret. A tooth can preserve shape, enamel thickness, root form, and sometimes proteins or DNA. It can suggest whether a person was modern human, Neanderthal, Denisovan, or something else. Yet teeth can also blur categories. Human populations vary. Similar traits can persist across groups. A single molar may carry enough information to open a debate, but not enough to close it. Some Asian fossils sit in a grey zone, perhaps representing populations that do not fit familiar labels cleanly. Ghost populations enter the story through another route. They're not found first as bones, but as statistical absences that behave like presences. Geneticists compare living and ancient genomes and sometimes find signals that suggest ancestry from a population no one has physically identified. These ghost groups may be deeply divergent relatives, unknown branches of Homo sapiens, Denisovan-related populations, or mixtures that do not match any sampled fossil. The term sounds spectral, but it is a confession of method. The genes imply someone was there. The ground has not yet provided their face. What survives in the record suggests that Asia was a place of unsampled humanity. A few ancient individuals turn these shadows briefly human. The Tianyuan individual near Beijing, around 40,000 years old, offers a glimpse of early modern humans in East Asia without serving as a simple ancestor for everyone who comes after. In Siberia, the Ust-Ishim femur, roughly 45,000 years old, belongs to a modern human whose ancestry split early from the lineages leading to later populations. He carries Neanderthal ancestry in long segments, showing that the mixing had occurred not too many generations before his lifetime. Yet his own lineage seems not to have contributed strongly to living groups. He's one of the clearest figures in the lost migration puzzle, undeniably modern, far from Africa, close to a great turning point, and still not a major ancestor of the present. Such individuals are not failures frozen in bone. They are evidence of a world in motion before later ancestry settles into more recognizable patterns. A person can stand at the edge of many futures, and most of those futures will not happen. Ancient DNA catches some of these abandoned futures. It reveals populations that split early, moved far, mixed with archaic humans, and then faded from later lines. If archaeology gives us footprints on a beach, ancient genomes give us footprints with family relationships attached, but only for the few individuals lucky enough to be preserved and sampled. Every genome is precious, and every genome is also dangerously easy to overread. One person is not a continent. This is why caves become so important and so misleading at the same time. Caves preserve bones, teeth, hearths, sediments, and sometimes DNA. They create the illusion that ancient humans were mostly cave dwellers, when in reality caves are simply among the few places kind enough to keep their traces. Open-air camps, wooden structures, shoreline shelters, and tropical forest occupations often vanish almost completely. Sediment DNA can detect human presence where bones are absent, but it may not show how many people were there, how long they stayed, or whether they were passing through. The cave record also shows that different humans reuse the same places across enormous spans of time. One layer may hold Neanderthal traces, another Denisovan, another modern human. A cave may not preserve a continuous community, but a sequence of returns by different groups under different climates. The presence of one population above another in sediment does not always mean direct encounter, and the absence of one layer does not always mean absence from the region. The record is layered, but life was mobile. In the humid south and island worlds, the mystery deepens because the evidence is more easily destroyed. Tropical caves can preserve fossils, but ancient DNA often degrades beyond recovery. Open sites disappear under vegetation, rivers, or sea level rise. The old Sunda landscapes, once exposed during low sea levels, now lie underwater. If early Homo sapiens moved through these plains, many of their camps are beyond reach. If Denisovan-related or other archaic populations lived there too, their physical record may be even thinner. Yet genetic traces in living people suggest encounters somewhere in this broad eastern world. The bodies of living descendants may remember meetings that the ground has almost entirely forgotten. Caves, teeth, and ghost populations therefore do not solve the lost migration mystery so much as sharpen it. They show that the human past outside Africa was denser than the visible fossil record suggests. They reveal modern humans who travelled far but did not become major ancestors. Denisovan-related groups known better through inheritance than skeletons, and unnamed populations that appear as shadows in genetic models. The more evidence is found, the less the story looks like a clean replacement of one humanity by another. It looks instead like a continent of overlapping presences, many of them real, most of them partial, some of them known only because a tooth, a cave floor, or a fragment of DNA resisted oblivion. The lost migrations are hidden in these small things: a molar held in a drawer, a bone splinter from a cold cave, a genome from a person whose people did not last, a signal in living DNA pointing toward a group with no known grave. They're not enough to restore every vanished community, but they are enough to prove that the silence is crowded. Once the clues have been gathered, caves, teeth, stone tools, genomes, ghost populations, the hardest question remains strangely simple. Why did so many early human presences fail to become lasting lines? The answer is not hidden because scientists have found nothing. It is hidden because they have found too many partial answers, each convincing in one place and insufficient in another. Climate explains some disappearances, but not all. Small population size explains some vulnerabilities, but not every pattern. Competition with other humans may matter in certain regions, yet it cannot be turned into a universal law. Absorption can erase a group without destroying it, but absorption itself requires contact, overlap, and time. The disappearance of early Homo sapiens migrations is not a single locked door with one key. It is a corridor of doors, some open, some broken, some painted onto the wall by evidence that only looks complete from far away. Climate is the first great suspect because climate has the power to redraw the map. A wet Sahara can invite movement, a dry Sahara can cut it off. Arabian lakes can become stepping stones during one period, and empty basins during another. Forests can expand. Grasslands retreat. Rivers alter their courses. Coastlines drown. And cold pulses can push animal ranges into unfamiliar patterns. For mobile hunter-gatherers, these changes are not background scenery. They are the structure of life. A migration that looks bold on a modern map may have followed a perfectly reasonable chain of resources at the time. When that chain breaks, the people beyond it may find themselves stranded in a shrinking world. What survives in the record suggests that many human movements depended on temporary ecological corridors, and temporary corridors do not promise permanent ancestry. Yet climate alone is too large and too blunt. Neanderthals survived many climatic swings before their final disappearance. Homo sapiens endured severe environments in Africa and later across Eurasia. Denisovan-related populations may have lived in cold highlands and other challenging settings. A drought or cold phase does not automatically erase a people. Its effect depends on population size, social networks, local knowledge, and alternative routes. Two groups can face the same changing climate and have different outcomes because one has neighbouring allies, wider exchange, better access to varied foods, or simply more people. Climate may close the trap, but demography often decides how tightly the trap holds. Population size is less dramatic than catastrophe, but it may be more important. Early dispersing groups were probably small, especially compared with the later expansions that became genetically dominant. Small groups can move quickly and adapt creatively, but they carry risks. They have fewer partners for maintaining genetic diversity. They have fewer experts in rare skills. They have fewer memories of distant places. They have less margin when seasons go badly. A large connected population can lose one camp, one route, one resource zone, and still recover through others. A small isolated group may not. The disappearance may happen not through a single fatal event, but through a slow narrowing of options, generation by generation, until the group is gone or absorbed. There is a lesser-known kind of vulnerability here, the loss of knowledge. Ancient humans did not survive by instinct alone. They survived through learned maps, tool traditions, seasonal timing, plant knowledge, animal behavior, fire management, shelter making, and social rules that helped people exchange information. If a population becomes too small or too isolated, cultural knowledge can shrink. A method for working a rare stone, a route to a seasonal water source, a technique for preparing a difficult plant, or the memory of when animals cross a valley can disappear if too few people know it. Archaeologists sometimes see technological change and argue over whether it reflects invention, contact, replacement, or loss. In lost migrations, loss itself may have been a quiet force. Competition with other humans is more tempting because it gives the story sharper edges, but it must be handled with care. Neanderthals and Denisovans were not passive obstacles. They were established populations with long experience in their regions. If early Homo sapiens entered their territories in small numbers, the newcomers may have found the best caves, hunting corridors, and seasonal refuges already known and used. Competition could have been indirect, not constant violence, but pressure over resources, space, and movement. A population that cannot expand because another group already occupies key habitats may remain small. If climate then worsens, smallness becomes dangerous. Still, scholars debate how often this happened, and the evidence rarely preserves the social details clearly enough to know. Disease is another possibility, though difficult to prove for such ancient periods. When separated populations meet after long isolation, they may exchange pathogens along with genes, ideas, and materials. This does not require imagining dramatic epidemics sweeping across continents, and the evidence remains incomplete. But even small disease burdens could affect fragile populations, especially when combined with climate stress, food shortages, or low numbers. Deep prehistory rarely leaves clear medical records. Bones may show some illnesses, but many infections leave no mark. Disease therefore remains plausible in some scenarios and almost invisible as a direct explanation. Technology may also matter, but not in the simplistic sense that one group had superior tools and therefore replaced all others. Early Homo sapiens did not carry a single magic toolkit. Stone technologies vary across time and region, and similar tools can be made by different populations. Still, differences in projectile use, composite tools, clothing, containers, symbolic networks, long-distance exchange, and flexible food strategies may have shaped survival. Many of the most important technologies were organic and perishable wood, fiber, hide, resin, cord, basketry, boats, traps, and carrying devices. Their absence from the record can make ancient people look less capable than they were. It can also make it difficult to know whether later populations had advantages that left few direct traces. Absorption is the explanation that most challenges the idea of disappearance. A population can stop being visible because it merges into another. Early Homo sapiens groups may have been absorbed by later Homo sapiens expansions. Some may have mixed with Neanderthals or Denisovan-related groups. Others may have contributed ancestry so small that later genetic drift erased or obscured it. In this scenario, the end of a migration is not a vanished campfire but a changed community. Descendants remain, but they no longer carry a clear label. The problem for science is that absorption can look like disappearance unless enough genetic evidence survives to reveal the blend. Replacement by later Homo sapiens waves may have been especially important. The later expansion appears to have carried broader ecological flexibility and perhaps larger, more connected populations. If these groups entered regions where earlier modern humans had already settled thinly, the later arrivals might not need to overwhelm them dramatically. Over generations, numbers and networks could do the work. Larger communities exchange more partners, spread more widely, recover more easily after local losses, and leave stronger archaeological and genetic signals. Earlier groups may have been folded into them or pushed to the margins until their distinct ancestry faded. Being first may have meant being exposed. Coming later may have meant arriving with momentum. Chance remains the most uncomfortable explanation because it resists narrative satisfaction. A landslide can block a valley, a lake can fail for several seasons, a key animal herd can shift its route, a neighbouring group can disappear, severing a marriage network, a storm can reshape a coast, a volcanic eruption far away can alter climate enough to stress already fragile communities. None of these needs to be the single cause of anything, but in small populations, chance events accumulate. History often remembers the survivors as inevitable. Prehistory teaches the opposite. Survival is partly skill, partly adaptation, partly numbers, and partly luck. The most grounded answer, then, is a layered one. Early Homo sapiens migrations vanished for different reasons in different places. Some were trapped by closing climates. Some were too small to persist. Some were absorbed by relatives or by later members of their own species. Some may have mixed with Neanderthals or Denisovans and disappeared as separate groups. Some may have left evidence now drowned beneath seas or destroyed by tropical decay. Some may not have vanished at all, but survive in signals too faint for present methods to separate. No single explanation fully accounts for this, and that is precisely what makes the mystery real rather than theatrical. The lost migrations were not one tragedy. They were many human outcomes scattered across a changing planet. The most misleading word in this story may be vanished. It sounds final, as if a people walked to the edge of a map and dropped out of existence. It suggests an empty camp, a cold hearth, a silence that follows the last member of a group into death. Sometimes disappearance may have happened that way, at least locally. Small populations can end. Harsh climates can close around them. Isolated communities can dwindle until no descendants remain. But in the deep human past, disappearance is often less clean than that. A people can vanish as a separate population and still survive as fragments inside others. A migration can fail to remain visible as a branch and still become part of a trunk. An ancient group can lose its name, its territory, its tools, and its recognizable bones, while a few inherited pieces continue quietly through time. This is the strange lesson of Neanderthals and Denisovans, and it applies with equal force to the lost migrations of Homo sapiens. Neanderthals are extinct in the ordinary sense. There are no living Neanderthal communities, no continuous Neanderthal language, no remembered Neanderthal homeland. Yet most people outside Africa carry Neanderthal ancestry. Denisovans are even more ghostly, known through astonishingly few fossils. And yet Denisovan-related ancestry persists in some living populations, especially in Oceania and parts of Asia. Their genes are not museum specimens. Some still function. They can influence immune responses, adaptation to altitude, and other biological systems. A vanished human group, therefore, can remain active in the living world, not as a people, but as inheritance. For early Homo sapiens migrations, Absorption offers a quieter but perhaps more common ending. Imagine a small modern human population living beyond Africa before the later expansion becomes dominant. They occupy a corridor, a river basin, a coastal plain, or a chain of valleys for generations. They are few, but not fragile in every moment. They know their land. They exchange partners with neighboring groups when possible. Then another population arrives, perhaps related to them, perhaps carrying different ancestry from a larger network farther west or south. The meeting does not need to be sudden. It may take place across centuries. People intermarry, camps merge, tool habits shift. Children grow up with mixed ancestry. Over time, the first group no longer exists as a separate lineage, but not because everyone died. They have become part of a larger population whose later descendants carry only a faint or undetectable trace of them. This kind of ending is hard for archaeology to recognize. A stone tool tradition may continue with changes, but the people making the tools may have changed genetically, or the tools may change while the population remains partly continuous. A cave layer may show new occupation intensity, but that could mean new arrivals, local growth, seasonal change, or better preservation. Ancient DNA can help, but only where DNA survives, and it rarely survives evenly. In tropical regions, in drowned coastal landscapes, and in acidic soils, the genetic record may be silent. Absorption may have happened many times without leaving evidence strong enough to name. There is also absorption across species boundaries, though even that phrase is too sharp for the reality. Neanderthals, Denisovans, and Homo Sapiens were long separated human populations, but they were close enough to produce descendants whose ancestry endured. The genetic exchanges among them were not accidents of a single night in prehistory. They reflect overlapping ranges, repeated contact, and human communities living close enough for boundaries to blur. Some early Homo sapiens-related groups may have entered Neanderthal ancestry long before the main modern human expansion. Later, Neanderthal ancestry entered expanding Homo sapiens populations. Denisovan ancestry entered some modern human groups farther east. The human family did not simply replace itself branch by branch, it folded back into itself. This folding changes how the lost migration should be imagined. A group of Homo sapiens that leaves Africa 100,000 years ago and leaves no major direct contribution to living people today might still have mattered. It might have carried genes into Neanderthals. It might have introduced habits, tools, or social connections that are archaeologically difficult to isolate. It might have survived for thousands of years before becoming part of another population. It might have left descendants whose ancestry later drifted away or became statistically invisible. The evidence remains incomplete, but the possibilities are grounded in what genetics has already shown. Deep human populations did not remain sealed from one another. The later success of Homo sapiens outside Africa may therefore be partly a story of accumulation. By the time the expansion after roughly 50,000 years ago becomes widespread and durable, modern humans are not moving through a world untouched by earlier attempts. They may be moving through landscapes already explored by prior Homo sapiens groups, already inhabited by Neanderthals and Denisovans, already crossed by forgotten contacts. Some knowledge may have been gained and lost. Some genes may have been exchanged. Some roots may have been found more than once. A later wave can appear new in the genetic record while still passing through old human ground. The ancestry of present-day populations also reminds us that survival is uneven. Neanderthal ancestry is broadly present outside Africa, but not identical everywhere. Denisovan ancestry appears in much higher levels in some populations than others, especially among groups with deep roots in Oceania and nearby regions. Different Denisovan-like signals suggest that the archaic populations involved may themselves have been diverse. This means that the eastern part of the human story was not a single encounter between Homo sapiens and one vanished people. It was probably a series of meetings with different Denisovan-related groups, some more closely related to the Altai Denisovans, others separated by long stretches of time and geography. The word Denisovan may cover a wide human landscape that the fossil record has barely begun to expose. For lost Homo sapiens migrations, this unevenness is a warning. The absence of a clear signal in living people does not always mean no contact happened, no people lived, or no descendants ever existed. Genetic drift can remove ancestry. Later population growth can overwhelm earlier signals. Some lineages vanish through chance. Others become so diluted that current methods cannot confidently detect them. Ancient genomes can suddenly reveal a population that no one knew existed, only to show that it contributed little to later groups. Every new genome has the power to redraw the map, but also to remind us how much of the map is still blank. Absorption also softens the idea of extinction without making it comforting. To be absorbed is still to lose a separate history. The names those people might have used for themselves are gone. Their stories, songs, relationships, and memories are gone. Their ways of recognizing landscapes are gone unless they were carried forward in forms we cannot identify. Genes are not the same as culture. A few inherited variants cannot restore a vanished people. They only prove that disappearance was not absolute. That distinction matters. It keeps the story grounded between two extremes, not a simple extermination myth, and not a sentimental claim that nothing was lost. The lost migrations of Homo sapiens may therefore be remembered as partial survivals. Some vanished completely, some left only tools, some left only disputed fossils, some left signals in archaic genomes, some were folded into later modern human populations. Some may survive as traces so small they have not yet been separated from the noise of ancestry. They are not the dominant ancestors of the world outside Africa, but they belong to the making of that world. They were early experiments in being human beyond the old range, and even when their separate paths ended, the wider human story kept some of their fragments moving. In deep time, a people can disappear from sight without disappearing from consequence. That is the unsettling legacy of the vanished migrations, not a clean absence, but a presence scattered too finely to gather back into a face. The fragments that survive have made the lost migrations visible, but they have not made them whole. In some ways, the mystery has grown sharper as the evidence has improved. Ancient DNA can reveal a vanished population from a bone no larger than a pebble. Proteins can identify a human relative when DNA has failed. Sediment from a cave floor can preserve traces of people whose bodies are gone. Climate models can reopen ancient corridors through deserts that now look lifeless. Yet every new method also exposes how much remains unseen. The record is not a window looking clearly into the past. It is a cracked surface catching flashes of movement. A person appears, a lineage branches, a signal flickers, a cave preserves one tooth. And then the rest of the world goes silent again. The first thing still hidden is the simplest and most human the faces. For Neanderthals, enough skulls and skeletons survive to give a physical presence, even if that presence has often been distorted by imagination. For Denisovans, the face remains largely unknown. A few teeth, a jaw from the Tibetan Plateau, small bone fragments, and genetic clues have opened an entire vanished humanity without giving it a full body. For early Homo sapiens migrations, the difficulty is different. Some fossils look modern enough to belong near us, yet their exact place in ancestry remains uncertain. Were they part of the population that later spread widely, or were they side branches? Did they look subtly different from later modern humans? Did regional variation matter more than the old categories suggest? Scholars still debate many of these points because anatomy alone cannot always separate a future ancestor from a lost cousin. Culture is even harder to see. Stone tools survive, but culture was never made only of stone. The most important parts of daily life may have been wood, hide, fibre, bone, resin, plant knowledge, carrying devices, containers, cords, traps, bedding, clothing, and social rules. A population with excellent perishable technology can look archaeologically poor if the environment destroys everything but flakes. A coastal group that relies heavily on fishing, shellfish, woven baskets, plant processing, and watercraft may leave almost nothing if its camps are drowned and its tools decay. This is one reason early Homo sapiens movements can seem faint. The people may not have been faint. Their materials were. Language stands behind the evidence like a locked room. Homo sapiens moving through Africa and beyond almost certainly depended on complex communication, but the archaeological record cannot preserve speech itself. Neanderthals and Denisovans may also have had sophisticated communication abilities, though exactly how their languages or symbolic systems worked remains unknown. When these groups met, they may have exchanged far more than genes. They may have learned routes, food sources, tool habits, or ways of treating unfamiliar landscapes. But language leaves no fossil unless it changes behaviour in ways stone, pigment, ornament, burial, or settlement can preserve. The evidence remains incomplete, and silence should not be mistaken for simplicity. The range of Denisovans remains one of the largest unknowns in human origins. Their genetic legacy suggests a wide presence across Asia, but the confirmed fossil evidence is sparse and scattered. Denisova Cave in Siberia provides the name. The Tibetan Plateau gives a high-altitude clue. Genetic signals in living populations point toward contact somewhere farther east or southeast, perhaps with Denisovan-related groups quite different from those in the Altai. This means the Denisovan world may have been geographically vast and internally diverse, but the map is still mostly blank. There may have been northern Denisovans, highland Denisovans, southern Denisovan-related populations, and others that differ as much from one another as distant Neanderthal groups did. The name may cover a family of populations rather than a single uniform people. The range of early Homo sapiens is also unsettled. Some finds suggest modern humans reached far outside Africa earlier than once believed, yet not every claim is equally secure. Dating methods improve, fossils are re-examined, layers are reinterpreted. Teeth once thought to settle a question may reopen it. A site can be old, but the human remains intrusive. A tool industry can look advanced, but its makers may not be modern humans. A fossil can look modern in one trait and archaic in another. The human past does not arrange itself neatly for classification. What survives in the record suggests repeated expansion, but the exact roots, pauses, retreats, and local endings remain difficult to reconstruct. There is another hidden layer, the people not yet named. Ghost populations in genetic studies suggest that ancient human diversity was greater than the fossil record shows. Some signals may represent unknown branches of Denisovan-related humans. Others may reflect deeply diverged modern human groups, Neanderthal substructure, or archaic populations that have no recognized bones. The surprising detail is that population can be statistically real before it is archaeologically visible. Mathematics can sense an absence shaped like a people, But until fossils, tools, or better genomes appear, those people remain outlines without faces. They are not fantasy, they are inference, and inference, however powerful, must be treated carefully. The same caution applies to the vanished Homo sapiens migrations. It would be easy to turn them into a dramatic legend, brave pioneers wiped away by deserts, swallowed by Neanderthals, or lost in a single catastrophe. The evidence does not support one grand scene. It supports a more intricate and more haunting pattern. Some groups leave Africa early and reach favourable lands. Some meet other humans. Some survive for long periods. Some contribute ancestry elsewhere. Some disappear from the detectable genetic record. Some may be hidden under the sea. Some may be waiting in unsampled caves. Some may be represented by fossils already found but not yet understood correctly. No single explanation fully accounts for this because the missing record is not one missing chapter. It is many missing pages from many different books. Technology may still change the story. Ancient DNA once seemed impossible from very old material. Then it transformed the field. Sediment DNA now allows caves to speak even without bones. Paleoproteomics can identify ancient relatives where DNA fails. Improved dating can tighten timelines that once floated across tens of thousands of years. Underwater archaeology may one day recover coastal sites from the exposed Ice Age shelves. Better sampling in Africa, Arabia, South Asia, Southeast Asia. And Oceania may reveal populations now invisible. The story is not closed, it is actively changing. That is part of its power. The lost migrations are not merely ancient mysteries, they are modern scientific frontiers. But even perfect methods would not restore everything. They would not give back the names of vanished groups. They would not recover every campfire conversation, every route taught across generations, every memory of rain in a dry valley, every careful decision that allowed a small group to move another season beyond the known world. Science can recover structure, ancestry, timing, ecology, and fragments of behavior. It cannot fully recover lived experience. The people who vanished from clear descent remain partly unreachable because all ancient lives are partly unreachable. What we still cannot see, then, is not empty. It is full of people standing just beyond the light Denisovans without complete faces, early Homo sapiens without lasting lineages, Neanderthals carrying traces of earlier contacts, unnamed populations hidden in genomes, coastal travellers beneath drowned shelves, forest dwellers whose tools decayed, and pioneers whose descendants were absorbed before they could become visible to us. The darkness is crowded, and every discovery shows that it has always been crowded. The last trace of a lost humanity is rarely dramatic when it first appears. It may be a tooth lifted from cave sediment, a stone flake beside an ancient lake, a faint patch of ash, a jaw fragment resting in a museum drawer, or a pattern in DNA that looks less like a discovery than an imbalance in a calculation. Yet from such small things, an enormous story has emerged. Homo sapiens did not simply walk out of Africa once and inherit the planet in a single unfolding line. They moved in pulses. They tested corridors. They entered green deserts that later closed. They lingered in hubs, crossed coasts, met other human groups, vanished from clear ancestry, returned in later waves, and sometimes survived only as a trace inside another people's genome. The story is not a march. It is a tide moving through a broken world. The deepest mystery is not that humans moved. Movement is one of the oldest human habits. The mystery is that so many movements appear to have been real without becoming lasting lines. Early Homo sapiens reached beyond Africa in windows of opportunity. and some of those windows may have stayed open long enough for generations to live outside the continent. They may have known caves in the Levant, lakes in Arabia, valleys on the edge of the Persian Plateau, forests and coasts farther east, and perhaps roots that now lie beneath the sea. They were not imaginary, and they were not meaningless because their descendants are difficult to detect today. They are people who found ways to live where their ancestors had not lived before. The evidence remains incomplete, but what survives suggests presence, adaptation, and repeated courage without guarantee. Later, a different kind of movement takes hold. Homo sapiens, already more ecologically flexible, already practiced in many environments within Africa, expand beyond the old range with more staying power. They do not conquer the world overnight. They pause, split, reconnect, and grow. A hub in Southwest Asia may hold them for thousands of years before wider dispersal. From there, some move toward Europe, where early groups such as those represented at Ranis and Zlatikun appear like brief lights near the end of Neanderthal Europe. Others move east and south through Asia, toward coasts, forests, highlands, and island crossings. Some reach Sahul, proving that before farming, before cities, before metal, human beings can cross water and enter a new continent. Yet even in this later expansion, some branches fade. The human story keeps producing first arrivals who are not final ancestors. The other humans of Eurasia do not stand outside this tale. Neanderthals and Denisovans are part of the same unfinished pattern. Neanderthals disappear as a living population, yet remain in the ancestry of many people today. Denisovans vanish almost completely from the fossil record, yet their DNA persists in parts of Asia and Oceania, influencing traits such as high-altitude adaptation and immune response. Early Homo sapiens groups may have entered Neanderthal ancestry long before the later expansion left Africa. Modern humans later carried Neanderthal and Denisovan fragments forward. In this braided inheritance, disappearance becomes difficult to define. A people can be gone from the landscape and still not be gone from biology. They can lose their separate future and still alter the future of others. This does not mean nothing was lost. Genes are not memories. DNA does not preserve a language, a gesture, a route name, a story told beside a fire, or the precise way a group understood the land. The lost migrations remain lost in every human sense that matters most. Their social worlds are gone. Their self-names are gone. Their songs, if they had songs, are gone. Their children grew into futures that either ended, merged, or were absorbed beyond recognition. Science can recover fragments of ancestry and movement, but it cannot return the full warmth of their lives. That is the quiet gravity of prehistory. It can prove people existed without being able to give them back. And still, the fragments matter. A lost migration changes the shape of the possible. It shows that Homo sapiens were testing the edges of the world long before the successful expansion became visible. It shows that deserts were sometimes roads, coastlines were sometimes archives, and caves were sometimes meeting points between different kinds of humans. It shows that failure, if the word is used at all, was not the opposite of human skill. A group could be skilled, alert, adaptive, and still disappear if the climate closed, if numbers stayed small, if networks broke, if later populations absorbed them, or if chance turned against them. No single explanation fully accounts for all of it, because the story is not one disappearance. It is many disappearances scattered across continents. The last trace, then, is not one fossil or one genome. It is the pattern itself, movement before permanence, presence before ancestry, contact before clarity. It is the knowledge that the world was once filled with human paths that did not continue in any obvious way. Some ended in dry basins. Some dissolved into Neanderthal or Denisovan worlds. Some were overwritten by later Homo Sapiens. Some may lie beneath modern seas. Some may wait in unsampled caves. Some may never be found at all. The lost mystery of early human migrations leaves us with a humbler image of our species. We are not the descendants of every brave traveller who stepped beyond Africa. We are the descendants of the lines that endured, merged, expanded, and happened to remain visible. Behind those lines stand others near ancestors, lost cousins, pioneers without lasting names, and vanished communities whose lives were real even when their legacy became faint. They remind us that human history is not only the story of survival, it is also the story of all the almost survivals that made the surviving world possible. The farther the mind travels back into this story, the quieter it becomes. The great maps fade first. Africa, Arabia, Eurasia, Sahul, Europe, Asia. These are names from a later world, placed over lands that ancient people knew by water, stone, wind, animal tracks, and remembered paths. Then the dates soften. 70,000 years, 50,000 years, 100,000 years become less like numbers and more like distances of silence. Somewhere inside those distances, people crossed a green desert that would not stay green. They slept beside lakes that are now dust. They followed coasts that are now underwater. They entered caves where their bones would not remain, and forests where their tools would decay into soil. They did not know they were early. They did not know they belonged to a migration that might be called lost. They knew only the ordinary pressure of living food, weather, kinship, memory, movement, care, and the next place where water might be found. For a while, that was enough. For some, it may have been enough for centuries. For others, perhaps thousands of years. Then the record thins. A route closes. A population merges. A lineage narrows. A later wave passes through. A sea rises. A cave roof falls. A genome keeps one small fragment and lets the rest dissolve. What remains is not emptiness. It is a kind of afterimage, a tooth in darkness, a bone splinter in cold sediment, a trace of Neanderthal ancestry, a Denisovan gift for thin air, a missing branch in a genetic tree, a coastline no one can excavate because it lies beneath waves. These are small survivals, but they are enough to remind us that the past was more crowded, more fragile, and more human than any simple origin story can hold. And perhaps that is the final image, not a victorious march out of Africa, but many small fires scattered across a changing planet. Some burn brightly and spread, some burn for a while and go out, some pass their flame to another camp before disappearing. Across deep time, the smoke rises, thins, and is carried away by wind. But for a moment, in the darkness before history, they were there,